Okay, AP Chem people, here we go. Hopefully the volume is okay. If it's not, that's all right. Just head over and get the notes off of the OneNote page. The link is in the Google community. All right, so we're going to start off. A couple things you got to remember. 7 strong acids and 6 strong bases. So remember, our strong acids are HCl, HBr, HI, HClO4, HClO3, H2SO4, and nitric acid, HNO3. Then our 6 strong bases are all of the group 1 hydroxides. And Serbaca hydroxides. Okay, we have to know those. So we're going to write some net ionic equations for neutralization reactions today. So a couple things to keep in mind. Acids equal proton donors, and bases equal proton acceptors. All right, and that's basically what we're getting at here. Acids transfer H to the base. Okay, so you can identify your acid, right, because it has an H out front, and take a proton off it, and then identify your base and add a proton to its formula. All right, so remember that the strong acids will completely ionize in solution, but weak ones, we will write them together. So strong acids are going to break up into their ions, like sulfuric acid here will break up into H, SO4 2- or H and HSO4. Either way you write it is fine, but just remember all strong acids are going to break up into their ions as H plus and Cl minus for HCl. Okay. Now there is one case in which you got to be aware that a strong acid will not break up is when they talk about concentrated sulfuric acid. You're going to leave that together as H2SO4. Okay. One other thing to keep an eye out is watch out for the SO2 and CO2, those gases being bubbled through water. What that is making is sulfuric acid and carbonic acid right here. So that's what you want to look at. And those are weak acids, so we would write those together. All right, so we're going to go through and do a couple of these ones. I'll do a few examples, and then the rest are there for practice. If you look over here on the right-hand side, you also have the acid-base net ionic key is right there on the next page, so you can check and see that your net ionic equation is written correctly. Okay, so the first problem here, we have a solution of sulfuric acid. All right, so sulfuric acid is H2SO4. It's a solution of it. It's a strong acid, so I'm going to write that as H plus and SO4 2-, right? Added to a solution of barium hydroxide. Well, barium hydroxide is one of our Serbaca hydroxides, so it's a strong base, so we can write that as barium ions and hydroxide ions. Okay, OH-. Now, when we react these, it's basically a simple double replacement. And with a strong acid and a strong base, one of our products is going to be water, liquid water, H2O, and that is a liquid. We write that together. That does not dissociate. And our other product is actually going to be barium sulfate, right? And barium sulfate would make a solid according to our solubility rules. So have your solubility rules out. We are going to be using them if you don't remember them. Okay? So and that is our net ionic equation right there. There are no ions to cancel out. No spectator ions. That's it. And on the next one here, we got hydrogen sulfide gas. So hydrogen sulfide is H2S. And they're telling us it's a gas. So when we write that in our equation, we write it as H2S gas. Plus, it's a weak acid, so we would write it together anyway. and it's bubbled through excess potassium hydroxide solution. So potassium hydroxide is KOH, and it's a group 1 hydroxide, so we would write that as K plus and OH minus. Okay, and in this case, right, we have our acid, H2S, and we're going to donate that H to our base, which is hydroxide, to make H2O, so we get liquid water, and HS minus, and then we also have our potassium ion still floating around in solution. So what we need to do there is we're going to cancel out our spectator ion. Oops. And then rewrite our equation here, and then this is our net ionic equation, H2O and HS minus. That is our net ionic equation then, after we cancel out our spectator ions. Okay, so we took that H off, and OH is our base. It's doing the accepting, and we write that together as water. All right, so we're going to continue to do that. So sulfur dioxide gas is bubbled. All right, so this is one of those SO2 is bubbled through. So that means that that is actually H2SO3. Okay, so we're going to start off by writing that as, that's a weak acid, H2SO3. So we'll put that there, bubbled into an excess of its saturated solution of calcium hydroxide. So calcium hydroxide. Now, calcium hydroxide is one of our bases. So we are going to break that up into its ions because it's a strong base. OH minus. All right. And hey, we take an H off of our acid and we put it onto our acceptor, which is HOH, so H2O. So we're making water. And HSO3 minus. And the calcium ion is still floating around there, not reacting with anyone. So we get, there we go. All we got for our net ionic equation then is H2SO3 plus hydroxide forming water and HSO3 minus. Okay. All right, so next one here. Next one, we got a solution of ammonia. So ammonia is NH3. And it's added to HF, hydrofluoric acid. So ammonia is a weak base, NH3, and HF is our weak acid. So we'd write those guys together. All right, and then remember, it's a proton donating and a proton accepting. So the donor is HF, and it turns into just minus. And it gave its proton to NH3 to make NH4 plus. All right, so there we go. So that's a weak acid, weak base interaction. Notice we didn't make water in that case. That doesn't happen all the time. Commonly with a neutralization reaction, you form water, but there's plenty of times it doesn't. And that's when a lot of times when you have a weak base and a weak acid interaction. If one of the acids or bases is strong, you're probably going to form water for one of your products. Okay. All right. So let's do a couple more examples. So let's do another one that was similar to. Actually, some of these are similar to what we've already done here. I'm going to skip over like hydrogen sulfide gas, like that was one, just like one we just did. Let's go with, so yeah, let's do number 3. Okay, so we have sodium hydroxide, NaOH, one of our strong bases, so we're going to write that as Na plus and OH minus. Is added to a solution of sodium dihydrogen phosphate, so that's NaH2PO4. So and that is also just a salt, it would be totally soluble, so Na plus and H2PO4 minus. All right, and we the OH is obviously our base, and it's going to take and accept an H from HPO4 minus to make H2O and HPO4 negative 2. And we still have some sodium ions floating around. Those sodiums would cancel out here. Okay, we would actually have two sodiums here, right? So I'm going to put it there and just cancel both those out, and then we're just left with our OH minus plus H2PO4 minus going to H2O and HPO4 minus 2. That's our net ionic equation for that one. Okay. Okay, so we'll move on to number 4 here. We got equal volumes of sulfuric acid and potassium hydroxide are being mixed. Both of those are strong acids. That's a strong acid of sulfuric acid and a strong base of potassium hydroxide. We break up the best H plus and SO4 negative 2 and K plus and OH minus. So we can break them right up into their ions right away. And ultimately you would form H2O, and your other product would be potassium sulfate, but that's soluble, so it still has K plus and SO4 minus 2 minus. So we cancel out our spectator ions. And, whoop, didn't mean to do that, so we would just be left with H plus and OH minus, forming H2O. So if you have a strong acid with a strong base, it's just H plus and OH minus forming water. Okay, which is obviously very different from our next example with ammonia, which is an H3, a weak base, reacting with a dilute solution of acetic acid, which is a weak acid, in which you form NH4 because NH3 is the base, it's doing the proton accepting, and the acetic acid there is doing the donation. So you got acetate ion floating around. That's it. That's that ion equation there. So you get the conjugate acid bases set up. All right, folks, you just have to get some practice going and go from there. Let me know if you have any questions, and we'll talk to you soon. Have a great week.